Hi, grade 9s. Today we're going to be going over some review for balancing chemical equations. If you feel like you need a refresher on the steps, go through the video lesson from last week. So I'm going to do just a few examples with you and then let you work. The first thing I wanted to point out is that these textbook numbers don't correspond with our current textbook. These are from the old textbook, so never mind those. The second thing is just a reminder of the diatomic elements. And so if you ever see any of the Hofbrinkel elements, just remember that those exist in pairs, so diatomic for 2. And so we'll put a little 2 next to them just to show that they exist in pairs. This homework assignment is going to ask you to write a skeleton equation for each of the following reactions. I just also wanted to talk about this term, skeleton equation. The skeleton equation is another word for an unbalanced equation. And then to fill in the coefficients, we'll make it balanced. Okay, so we're going to start with just the skeleton equation, and then we'll balance it. So for the first one, we have hydrogen and oxygen yields water. So H plus O yields H2O. But then you also notice that the hydrogen and the oxygen are part of the Hofbrinkel, so I need to put 2's there. And then I suggest also having to show all our work. And so I would just do a quick chart of the reactants and products, hydrogen, oxygen, hydrogen, oxygen. I start with 2 and 2, and I end with 2 and 1. And so then going through, you would notice that we need to add another oxygen. We can't add subscripts because that would change H2O2. H2O2 would always actually be hydrogen peroxide. And so we don't want to do that. And so we could have a coefficient in front of it instead to show that we have 2 water molecules. And that means that I have 2 H2s and 2 O's. So that means I have a water and another water, and that means I have 4 hydrogens in total and 2 oxygens. So now my oxygens are balanced, but I need to add some more hydrogens, but I can easily just add a coefficient here. And now I have 4 of each, so we're good. 2 more examples. I'm just going to get the second one started, and then I'll let you finish it. Just a reminder, if we have a Roman numeral 3, that means that our charge is 3 plus. The metals are always positive. And then oxide, look it up in the periodic table. You'll notice the oxygen ion, or the oxide, is 2 minus. So you're going to have to do a little bit of crisscross here to figure that one out. And then I'll let you figure out the rest. The last one I wanted to point out was calcium carbide, because this is a tricky one. I had to look it up as well. Calcium carbide, if you looked it up in the periodic table, carbon has different charges. And so I had to look this one up, and I figured out that it's actually Ca2C. So I'll give you the formula for that one. The rest I think you should be able to figure out. Let's take a look at the second sheet for your homework. For this sheet, same thing, just ignore the textbook pages. That's for the old textbook. Rewrite the following sentences as chemical word equations, which then write the skeleton equation and balance equation. So once again, this is the unbalanced, and then we're going to balance it. So here, we're going to have iron combines with oxygen to form rust, which is also known as iron 2 oxide. And so our word equation, we're just going to take these words and just put them in here. So iron combines with oxygen to form rust. We're not going to write rust, we're actually going to write iron 2 oxide. And then for the balance equation, we're just going to rewrite this with symbols and then add coefficients to balance it. So we'll write my skeleton equation first. Iron, because it's a metal, no coefficients needed. It's just Fe. I don't need to specify which iron. I can just write iron. And then oxygen, write the O, but remember the Hofbrinkels, so I'm going to put 2. And that yields iron 2 oxide. If we wanted to write the formula for this one, remember the crisscross method, iron Roman numeral 2 is 2 plus. If you look up oxygen in the periodic table, you notice it's 2 minus. They already balance out, so I don't need to write Fe2O2. FeO is fine because they already balance out, and so I can just write FeO. And then I'm going to take a look at them, and I notice that my irons are already balanced. I have 1 of each, but I have 2 oxygens here and only 1 oxygen here. So I will add a coefficient here to add another oxygen. But that means I need to add another iron, so I'll add another coefficient here. So that's it for today. I'll let you work on it, work on the rest of it on your own, and then also remember to finish your video submission for your second video. If you need more time or if you have any questions, feel free to let me know. Okay, class, take care. Bye.